Okay, looking at question 4 in this worksheet, I know this second part, which should say B, is giving a lot of people some difficulty. So we're going to look at it here real quick and work through this entire problem, and then I'll show you how I actually calculate it. Alright, so we're looking at lead iodide, PbI2, and we got a KSP of 7.9 times 10 to the ninth, and at first we just want to calculate its solubility in pure water. So we have our basic solubility product equation, which would look something like so, because it's turning into lead and 2 iodines. And I'm going to plug in that 7.9 times 10 to the ninth for the KSP, and for our solubility, molar solubility, we would see that for every S there is 1 lead, and for every lead iodide there would be 2 iodides. That's going to turn into 4S cubed. So our S is, let's see, 7.9 times 10 to the negative ninth divided by 4, and then take the cube root of it. And I end up with S of 1.25 times 10 to the negative third. Was that negative third? Yeah. Alright. The second one's going to have a slight complex nature to it because that 0.5 added to it. Alright, so our basic overall equation is the same, and it is still the 7.9 times 10 to the negative ninth. But now instead of S times 2S, it's S, and in addition to the 2S, there is 0.5 molarity of iodine, so we're going to work that in. That's going to go up by that. Alright, now, this is solvable just like so, and I'm going to show you how to do that in just a second, but we can also make an assumption. See how small this number was before? When we throw this in, it's only going to make it smaller. So we're going to try an assumption where we just assume that the 0.5 is so big that we can ignore the S, at least for the iodine. And if that is the case, let's see what we get. 7.9 times 10 to the negative ninth, and I'm going to divide that by 0.5 squared, and I get an S of 3.16 times 10 to the negative eighth. I guess I need units on both of those. And I'd be perfectly happy with that value. It's going to be close enough to the real thing. It is a really, really small S, so that is a safe approximation. But if you happen to have a graphing calculator, you can plug this straight in and solve for it exactly. I'm going to show you how I do that on this. So I just hit the graph, the y equals button up here on my calculator. And what I'm going to do is put this in pretty much as it's written. Obviously I can't do S's, so I'm putting in X's. And I want to move this over there, so I'm subtracting 7.9 times 10 to the negative ninth. Remember, when we do a line, we want to put everything on one side and have it just equal to y on the other side. So that is our entire equation, and if I hit graph, it actually does try to graph it. I'm really not worried about what it graphs. What I'm worried about is what the value of S is, and I'm looking for a positive number. So I'm going to calculate that 0, and I know it's somewhere between 0, and I'm just going to go up, and as you can see on this graph, it's going up. So I don't know how large it is. I know it's a very small number, so it doesn't really matter what I put in there. And then I'm going to back up here on my guess and then let it come up with a number. And if you look, 3.16 times 10 to the negative eighth, the same thing that we approximated.